So this is the relational algebra. Actually, probably submit asterisk from employee where SSN like this curve. Then convert the relational algebra. Then it will form what? The Curie tree. Then apply the heuristic rules. So we ignore in this case the heuristic rule to focus on the cost base optimization. So we have one table. So how many? There's no join and only one way to access the table. So we can consider only the selection part. So we can compute all S1 to S9 cases, but obviously we can take out some part if there is no clustering index, if there is no relation for the clustering index or other index, we can ignore only these two cases can be considered. One is brute force way, another one is using, this one is SSN is the secondary index, right? So we can consider two cases among 9. So first one is a brute force way. It's a half, it's a exact curve, equality curve. How many? So 2,000 blocks. So on average, 1,000 blocks, which means cost is 1,000. In case brute force, without using what? Without using index. Some may be curious. What if 1, 2, 3, 4, 5, 6, 7, 9 is the first block? It will take just one block. Yes, that's true. Sometimes it can be 2,000. You need to access all the blocks. On average, it's 1,000. Okay? So the cost is 1,000. It's the best estimation. What if we are using the index for this SSN? How many level? 4 level. Okay? Plus 1 for data block. How many blocks? On average, 5 blocks. Which one is better? S6 is better, right? It takes a 5 block, it takes 1,000 blocks. So Curie optimizer will select this one, which means when you access the employee with the social security number 1 through 9, we'll use this secondary index of SSN, then get the data block. Okay? That is the Curie optimization. What about the next one? This is the same, but D and O 5. At this time, do we have index? Yes, we have index for the cluster index. For this one, let's see, DM, right? So level is 2, and leaf node is a secondary index. It's a B plus 3 index. Okay. So in case of a brute force, it's a 2,000. What if using index? It's a level is 2. Then this one is for what? Leaf node. How many leaf node? 4. It's a half. It's a 2. And total number of employees divided by 2 is a 5,004. This is a cost function. Is it true? It's the best estimation. Okay? Then what if brute force? It's a 2,000. In this case, this one is better, even though we have index for this. Okay? So this is a common mistake for developer. Index is always better. Index provides the best performance, not always. Okay? Not always, depending on the data. The third one is the DNO is equal to 5. Even the only difference is operator. Inequality instead of the equality instead of the inequality. So 2,000. In this case, because it's equality, in case of the equality,
it's x plus s.
Where is it?
X.
Not this one.
2.
Primary index, S1, linear search, binary search. The index which is a multiple record is in cursor. Yes, here. So it's a By the way, DNO equal to 5 is this one. So it's just a level plus 1. Level plus 1, but selectivity, how many data will be returned for one index is 80. So it's 82. Okay? Which one is faster? This one is faster, so this one will be selective. Difference is only the operation, but huge difference. And this is conjunctive. Conjunctive means it's a combination of the different operation. Okay? So DNO is equal to 5. It has the index. What about the salary? Salary, do we have index for salary? Yes, we have salary index. Also, do we have index for sex? Yes, we have index for sex. That is this one. So we can consider 3 different cases plus 1. One is a brute force. Brute force is always the case, right? So it's 2000 and DNO is equal to 5. Okay, we already did before. And what about the salary? Salary is the range theory plus the 2003. And in case of the sex equal to F is the level x1 plus the selectivity. Cardinality is 5,000 because it's a half and half. So 5,001. In this case, this one is the lowest cost. Which means the query optimizer will ask to access the employee data using the DNO index. Okay? That can minimize the cost. So that is only first. What about the multiple tables? Which means the join condition. So, in case we have the join condition first, we need to consider join selectivity. How many data will be returned when you join two tables? Okay? At this time, to decide such a join selectivity is R and S is the each table. Okay? R and is. So this is the size of the result when you join two tables, R and S. Sum of data will be matched with the join condition. This one will be saved here. That is this one. So join selectivity is a percentile. Actually, it's the same as the percentile, the 0 to 1 scale. What is the join selectivity between R and S and number of the tuple of first driving table and driven table, two tables, and multiply. So for example, if this one is 100, this one is 10, and only 10% is joined, then 100 times 10 times 0.1. Okay, then that will be 100. Is the join select. This is this part, and divide by the Cartesian product of R and S. This is a join, but total 100 times 10 times and absolute value. So this will be the 1/10. This part. Okay. This is the join selectivity.
Is this for any query? Like, I can make the query in different ways.
That will be here, the nested loop join. We will see in case of nested loop join, in case the single loop join, in case the short merge join. We will see. So join selectivity is what is the in case of join, what is the common between R and S? That is a lot of idea of the join selectivity. What is the percentile? Okay. So, for example, if all of them are matched, it will be 1. If none of them are joined, it will be 0. On average, how many of them will be joined? From 0 to 1. So to compute that one, this one you should be invested. Actually, during the collecting information, it will be calculated, the JS. Then multiply by R, multiply S, divide by the Cartesian product, all the cases. partition all the cases, how many of them are matched. So between 0 to 1. 1 means all of them are matched. 0 means none of them are matched. Okay? Using this one, we have the nested loop join. Nested loop join is a two loop join. Okay? So which means for each block in R, private table, okay, outer table. For that, for this one, match all of inner table, variable table. And next, for each, how many cases? BR block, number of block of R times number of block of S. Okay, all the cases. Because you need to anyway access all the block. For this block, all the block. For this block, all the block. Okay, what block? Then you need to access this amount of data vector join. This is divided by blocking factor because this is number of rows behind it. So how many blocks will be joined? Okay? So this is the nested loop join cost function. What about the single loop join? Single loop join, you don't have to access entire of inner table. Instead, you can use index. Then directly find one block. You need to add cost. Instead of entire S inner table block, instead you need to add index cost. Then just one, which means you can see this part as the cost of accessing index instead of all S. So for each the outer table, okay, and this is a join. So after join, you need to access this one. They are common. This part is the index. As you can see, if you are using the secondary index is a level plus selective, the cardinality. In case of clustering, this is the cardinality of the clustering and divided by the blocking factor. And primary index is a plus always plus 1 for each one. Not number of R, number of block for each row in R. So that is the reason is the number of record of R. I'm going to the hash part. Depending on the hash function, it's a little bit different. So I'm going to skip this part. What about the sort merge? Sort merge, you are going to sort this one, you are going to sort this one and match from the top. Okay? So definitely we have the same thing doing selectivity over here. Access all the row in all the blocks left hand side, all the block right hand side. Problem is this one. It's a cost function for sorting the table. It depends on the sorting address. Okay, so that is the reason cost for sorting is just a Z. Okay, if you have the sorting algorithm, you can use that one. It depends. Okay. So this is the join operation. So let's take a look at the example of that. So we are going to use the same table to here, and this one we need another table. In this case, department table. Okay, the number of department is 125. And block, we need 13. What is the blocking factor? Blocking factor of E is 125 divided by 13 and 3. Right? And also this table has the primary key. What's the level of the primary key? 1. Only one block need for this. And secondary key, we have the manager social security number as the index of the department with as manager social security number. What does that mean? Selectivity of manager social security number is equal to what? One manager for the department. Right? Selectivity. When you provide 111 manager SSN, how many? Only one data. And what does it mean? X level of managers under social security number index. It has two levels. Like this. Okay? And we need joint selectivity. Okay? In this case, JS is 1/125. Why? When you join with the D NO and D number, okay, one department will match with one employee, manager, social security. Okay, at that time, blocking factor of the joint table, which means this one after join, this is the 4. 4 record will be in the one block. Usually it's in the memory. So we are going to optimize this query. Employee join with the department with the join condition D NO is D number, which means select asterisk from employee and department where D NO is equal to D number. There is no selection condition. In case you have the select condition here, you can apply heuristic rule first. Okay? Then you can minimize. Then the computer of course to decide which join operation is the best one. Okay. First, nested roof join. Nested roof join is the employee and department. For each employee, access each block to find next employee to find that. Okay, so for each employee, you need to access this amount of time. B time number of blocks, employee number of blocks, department. Then this is a joint select 1/125, and all the record of employee, all the record of department, and divide by buffering factor, the blocking factor. Okay, then that will be 30,500 blocks. Okay, of course. What about this? Is the employee as outer group, like this one. Also, we can consider department first and employee. So outer is the department, inner is employee. What's the difference? So PD for each department block and compute this might be the same, and this is the same, this is the same. So output is 28,500. The difference is this one. As you can see, they are different even though they are accessing the same table, same nested roof join. Depending on the order of accessing the data, their costs are different. Okay, so as you can see, usually smaller table should be outer table, driving table. Okay, that makes sense. For each smaller table, access the data. Then this one is the single loop join. Single loop join, employee then using index access the data. Using index access the data. Okay, so for employee, because employee is our table, so we can consider D number. When you access department, for department we have the D number index. Of course the level is 1, so that's plus 1 for each employee. Okay, this is the same as this one. So have to compute the cost. It's 24,500. What if change the order? Department first, then use the index for employee. Okay, so that is all the blocks in the department and all department record. Then in this case, we are going to cluster index, right? For the DN. So that is the selectivity is 80. Can you remember this is selectivity 82, and this is the same as this one. It will be 12,700. What about the sort merge? Sort merge we do not have cost of the sorting, so we do not consider that one. Among them, which one is which way will be selected to access the data? In other words, which one is the fastest way? This one, which means access department first. Okay? Then find the employee using the index of employee, DNO index in employee. Then access the table, the join. Make the join area, a join block. That is the 12,763 cost. IO are required. So this way will be used for optimization. Okay, so you will see more details example in the handout. So why don't you take a look at this one? Definitely I'm going to make the couple of questions from the handout to compute the cost function. Okay? So that will be the part of the final exam. So today we are going to start here. The next class we will discuss about the transaction management as well as the concurrency control. Okay? One more time, our final exam is the May 8th, the Thursday, so 1:45 to the 3:45. Okay, so at the time, the final exam will cover after midterm. Okay, and if you have any problem or question regarding to your grade or homework, anything except the final exam, you should contact the GA. GA will be available during his office hour in the Tech 163 because it provides more room to meet the student. So the rest of the semester, the next 2 weeks or 3 weeks, so you can find him at the Tech 163, or if that is occupied, the cubicle area. Okay. And the next week, Tuesday, we will have the final exercise lab. At the time, using Oracle, you can test the query optimizer. And also, Thursday, you will have the demonstration for the project A and B. For undergraduate student, if you did complete and submit for the project B, you can demonstrate also. Otherwise, you can just demonstrate project A as a group. So one of the students can attend and demonstrate. Okay. Anything else?